I am Ian Anderson. I am Associate Director within Analytical Sciences at Pharma Gene Therapy here in Liverpool. We've been working closely with Waters to really look at how we can improve the analytics to help get these important life-changing therapies to patients quicker. And that's really been our focus for the last 5 years. In our labs, we've been using the Waters Vion and the Waters Synapse systems to characterise AAV critical quality attributes. One of the big challenges with AAVs is the size of the molecule. It's a really big molecule, it's very complicated. So we use our orthogonal approaches with both the Waters Vion and the Synapse to get different information about the product. The Vion allows us to look at it from a smaller scale, whereas the Synapse allows us to look at the AAV from an intact perspective.
My name's Paul and I'm a Senior Technical Specialist within the Analytical Development Characterization Group. My day-to-day role involves characterization of various protein therapeutics, including AAV and various serotypes of.
Hello, my name's Lauren Tomlinson and I'm a Scientific Associate 3 working in the Characterization Department of the Analytical Development team. So I was once a placement student here 7 years ago and that's when I started using Waters instruments on the Xevo in particular, and then I finished my undergrad and then started a PhD with Claire Ayres at the University of Liverpool, and that's where I spent 4 years using the Waters Synapse instruments. And then because I enjoyed it so much at the placement, I decided to come back here and carry on using the Waters instruments.
Looking at things like post-translational modifications as potential critical quality attributes to be investigated and monitored. Unify is really good for this. It prevents like an all-in solution from data acquisition, method creation, analysis, and data interrogation, viewing and reporting. And it serves as a good basis once we've got this really in-depth understanding of the various PTMs and potential CQAs that we can use to underpin something like a multi-attribute monitoring method within the same framework. We also do intact mass analysis, and to support this, because of the various challenges you get looking at different serotypes of AAV, we look at different separation chemistries, and we need good robustness with that separation and instrument performance. By doing this, we can resolve out the various capsid proteins from one another and get an understanding of the stoichiometric ratios between VP1, 2 and 3.
So part of my role is looking at intact AAV particles by using the Synapse MS. So this is a challenge because AAV particles are such large in size. So this is challenging, but with the use of the Synapse, with the 32,000 quadrupole, we can analyse these proteins and go up to a much higher mass range. So one thing that we look at is looking at the VP ratio, the 1:110, which is expected, and then we can look at this, but look at the different stoichiometry to see if the ratios are within the expected range. If these are not in the expected range, then this can have a problem with the vector potency. So it's very important that we look at this in the early stages. We can then use a UV or a FLR detector to then determine the peak area ratios and to quantify this range. The sample prep is very quick for this method. We just need to acidify the sample, and then we centrifuge and then use a BEH column, and this is only for a 30-minute gradient, so super fast analysis. And then we also use the Synapse for direct infusion, so we use this for looking at the AAV particles natively, and this can be done by buffer exchanging the protein into a volatile solvent such as ammonium acetate.
As part of our peptide mapping approach, we need flexibility because digestion of the capsid proteins can be challenging. So we look at digest using various proteases, which is something that we can do with the Unify software. So that flexibility is really important for the characterization stage, so that when we characterize the product, we can be sure that we've seen everything that there is to see. And if, for example, we want to move a method into QC release, a MAM type method, we are confident that we have seen everything within the product that needs to be identified so that we don't come across any surprises at that late stage.
So again, it's important that we have this larger quad that we can actually detect this protein. They have full capsids will have a larger CCS in the 62,000 angstrom range, whereas an empty capsid would have a CCS in the range of about 56,000 angstroms. So we can then quantify the empty-full ratio by looking at the differences in the signal clusters.
So where Waters really stands out as a vendor is when it comes to technical support. So I found it really easy to get in touch with someone to get advice and to resolve any issues that come up. The response is rapid and the quality of the support is really excellent.